Okay, guys, so in this experiment, we're going to be making a polymer. So we're going to be making nylon specifically. So this is the materials that you use in like some clothing and everything. Nylon clothing is kind of the main place I've seen it, at least. So we're going to be making that molecule. So the two different molecules that we put it together in order to make nylon, the molecule in pink is a diamine. So there's two amine functional groups on it. And then we also have the molecule in blue, which is it's called a acid chloride, but that's not a functional group we worried about learning, but it's a very similar functional group to maybe like a carboxylic acid. Just think of it as that. We just have a chloride or a halogen on the end. And when these two things mix together, they react really, really fast with each other. And the amine will make a bond and kick off the chloride. So the chloride leaves. We'll learn reactions kind of like this, but not exactly like this later as well. But uh, this happens really fast, and so you can constantly have this reaction going. So the diamine is actually soluble in water, and the acid chloride is not. And so what we'll do is we'll have one dissolved in an organic solvent, something more not soluble in water, kind of like oil and vinegar. How one is an oil, one is water-based, vinegar is water-based, so they don't mix together. So we'll put one of them in an oil-based solvent or organic solvent, one in water, and layer those two solutions, and then at the interface of the layer, the reaction occurs between the two different molecules, and we can pull out a polymer. So we'll get this reaction just over and over and over. Each end of each molecule will react and form a really long strand of the molecule of this polymer. So this one's a fun one to do and to watch, so I hope you guys enjoy. Okay guys, so let's actually do the experiment. So here I have my amine in water. I'm going to pour it into my first beaker. Okay. And then I also have my acid chloride in this solution here. It's dissolved in hexanes. It'll go into my second beaker. Oops. Okay, so as we discussed, looking at the structures, when I layer these two together, since one of them is dissolved in water and one is dissolved in hexanes, we're going to have two layers of liquids, just like oil and vinegar in your salad dressings. So I'm going to pour the one in hexanes, which is the organic material. I'm going to do what's called decanting. I'm going to pour it over the stir rod so that I can make two layers. Ooh. I can make two layers as best I can without disturbing the film that I'm forming in between. I'm not doing the best job at this though. Okay, so at the interface of these two materials, I can see it, I don't think you guys can see it, but there's a little bit of a film, and I can pick it up now with these forceps, and I'm going to just move this over a little bit. So at the interface of those two materials, or those two solutions, is where my polymerization reaction is occurring. And now I have this material that hopefully, if I do this correctly, I can start pulling let's try that again. I can start pulling a nylon thread constantly out of this solution. Let's try this way. Well, it's it's working. So until those materials run out, this is going to keep pulling a thread of polymer. This is not working as well as I hoped it would. You guys get the picture. Oh yeah. It's sticking to the side of the beaker, so it's not. You see that? It keeps sticking to the side of the beaker instead of going up. But this will just keep going and going and going and going. So those small molecules are interacting at that interface to make one big long molecule. So this is nylon. It's the same material that you see like nylon clothing made out of. This is the same process that they do. They, much more gracefully than I did, they will pull the material out of two solutions just constantly and make really small threads and then weave those together into material. See how long it'll go for.
Allie's gonna weave a class shirt for everybody.
Yes. Everyone will get a shirt at the end of this made out of
Fresh nylon.
Fresh nylon, yes. Okay guys, I'm back with our nylon here. So this ended up going for about 25 minutes or so, and this is how much thread we got out of it. It's pretty cool. Okay guys, so in cleaning up this demonstration for you guys, I just wanted to show you one more thing. It's a little wet and gooey, but it kind of looks like slime, our polymer that we made, our nylon. But I wanted to show, it's going to have water drips, so I'm going to stay over here. But when I pull on this, let's get some of that water out. Oh, that's gross. Yummy. Okay, but when I pull on this, it's like a thread. I'm pulling pretty much as hard as I can, and all that's really happening is that the water is coming out. We're ripping a little bit of threads off the edge, but it's one big molecule that's not covalently bonded, and it's hard to pull apart. It's a polymer. Oh gosh, whoops. My hand slipped and I ripped some of it, but you can see all those little threads in there now that you couldn't see before of the polymer. This is pretty gross. We had fun.